Okay, so let's start it. First question, are there any Solidity developers, at least bad ones like I am? Okay, so I will try not to make it too much technical, but provide like bigger overview. So yeah, I'm going to speak about open source tooling. And I'm Josef, I'm co-founder of Ackee Blockchain Security. We are smart contract auditors. And we are also, from the very beginning, big believers of open source. So we are constantly trying to develop some tooling that will be beneficial also for the others. So everyone is free to use the tools that we produce. And this would not be possible without our clients that pay us for the audits, and from the profits we can be doing such stuff as creating open source. So thanks to Safe or Axelar and many others that we are working with. We also got a grant back in the day from Ethereum Foundation. We got a grant that supported development of this tooling from Coinbase. So all these big players helped us to create the tool. Before I deep dive into the tool, I will just do a quick recap of some, let's say, best practices in security. We see security like this. So we are auditors. We are selling this part of security, which is the most expensive one, but I openly admit that it has the lowest impact. So basically, the most impact in security is still on the development teams. And these are the 4 stages that developers can do themselves. They don't need auditors for that. And so what is it? The very beginning, of course, some best practices. Still, we are seeing some repos, for example, created by one developer. This doesn't work. So, of course, do your peer review. There is a GitHub flow for that, so just use it. Second stage, everyone can do it for free. It's about tooling. So if you just select the right tools to secure your code, you get some extra layer of protection and security. So there are tools such as Slither, which is the static analyzer from 12 bits. There's our framework. There's many commercial tools. So use tooling. It's for free. The first stage, which should be still standard, is of course writing test cases. So every project should have test coverage between 80 to 90%. If you reach an auditor without having your project fully test covered, you are wasting your money basically. So this is also something that every development team can do themselves. And of course, it's good to cover not just the happy path scenario, but also some kind of like edge cases in the test suite. For this, of course, you need a framework to write the tests in. And this is something I would say very few developers do, but still developers can do it themselves. It's about fast testing. So fast testing, it's a technique basically where you try all possible inputs on all possible functions in all possible orders. But the problem is that this is so-called black box fast testing. It takes ages because the smart contracts are complex. So the fuzzer may never finish fuzzing because there are so many possible combinations. So how we approach to fuzzing is that we basically like narrow the space of possible states by guiding the fuzzer. And we call that flows. So basically we define for the fuzzer where should it go and where should it not go. And by that we are kind of like cutting the space in with our framework. But of course there are many other fuzzing frameworks. And in the end, like running a fuzzer is against the thing that every developer can do himself. And then on the top of the iceberg is audit. And now this is the tool that we have created. It's called Wake Framework. So what is it? Basically, this is the logo. Yeah. First part is static analysis framework, which is something we can compare it to Slither. So basically, you run it over the code base, and it returns some findings. The program snippets that run the reveal the findings are called detectors. And always the problem with detectors is to produce as less as possible false positive, because then no one uses that. Second thing we do with Wake Framework is a testing framework. So basically, this is the tool where you write your tests in. And also, we were missing a debugger. I will tell you how we solve this problem. And we offer part of the testing framework, the fuzzing framework. And there is a language server. I'll speak about it later. So this is how it looks when you run the CLI tool over your code base. This is the output on the terminal, and this is the static analyzer. And here you can see that it shows the line of the code where is a possible finding, and there is some kind of like severity detection between medium and high, and then it writes what is the problem. So this is something you get completely for free if you run the tool over your code base. Then as I was speaking, like right now, it's still kind of hard to debug Solidity contracts because there is no debugger. There is some development in that, but still, as we are facing the problem how to debug basically contracts, we came up with a solution, and basically we have transformed the problem. So we have created this framework that basically takes as the smart contract on the input and creates a model in Python using PyTypes. So in the end, we are using Python tooling to debug Solidity smart contracts. Here you can see this is the Python IPDB debugger, and it's debugging Solidity code. So basically, it's not debugging exactly Solidity code, but it's debugging the model that was created from the Solidity contract one-to-one using Python PyTypes. So with this kind of twist, we are able to use the very rich Python ecosystem to debug the Solidity contracts. And it's part of the tool, so you can use it, of course, for free as well. The next part we are covering is the fuzz testing. Here you can see how easy it is to write fuzz tests in our framework. So in our implementation, the fuzz tests consist of two things. One is invariant, which is basically a definition of some state that can never happen, such as balance of this address should never be below 0. If this invariant is broken, something is wrong. And then we define the flow, which is the instruction for the fuzzer, which functions should it fuzz and how. And by these tests, we are able to find pretty much problems, for example, in DeFi mathematics. And this is something like kind of crazy stuff we can do with fuzz testing as well. Imagine that you have, for example, third-party library in Solidity that is doing some kind of mathematic calculations. You are using the library in your project. And of course, to audit the library would be extremely costly. But still, you are relying on the library, so you need to a little bit know if it works or not. And we have been having this problem with audit of project IPOR, which is basically a huge DeFi protocol. And our solution was that we have taken the library that we are not sure about how it works, and we have found an equivalent library in C language that basically is used for decades. And we just wrote a fuzz test that was trying to put the same data in both libraries, and we are just comparing the output. So we were not really like looking code review of the library. We just compare if the outputs of the testing of the Python of the C library that was like Battlefield tested and the Solidity library are the same. And we have discovered that in some edge case, which of course was some kind of like rounding error, the Solidity library is returning different results than the C implemented library. And by this approach, we are able to really effectively find some problems that would be extremely costly to discover by a manual code review. And does it work? Yes, it kind of works. These are the findings that were discovered by our tooling, not by manual code review, but purely by fuzz test or by detectors. And you can see that we have hit quite high-profile projects. So, for example, last month we have found a medium severity issue in Lido in contracts that were audited many times before that. We also have one medium in Axelar, high in Brahma. So this tooling kind of like is delivering some results. And it's in Python. So everyone would tell, hey, Python, it must be slow. So we have just created a benchmark where we have implemented 271 unit tests of Uniswap v3 in our framework in Wake. And we also re-implemented that in Ape and Brownie just to see the comparison. And we have run this test suite of 271 tests over these 4 frameworks and on 3 different chains. and we are just like measuring the results. And we can see that when we use Wake with Anvil, it's getting the fastest results, and it's in seconds. So it takes the test suite takes 3 seconds, which is like 10 times faster than, for example, Brownie on Anvil. So this is extremely important because when the test suite is taking too long, then people will, for example, drop it from the CI/CD pipeline. So you don't want to have a test suite that is blocking your deployment. So it needs to be fast. And if we compare like all the open source tools that are on the market, you can take a picture if you want. Here is a table. So basically, there are some tools that are just like for security, some are testing frameworks, and our goal was basically to cover all these features into one tool. And we still have time, so there's more to that. Wake is a CLI tool framework, but we also have frontend for that. That's thanks to language server protocol, which is basically a protocol that allows to communicate from developer environments with CLI tools or libraries. And in our case, we have implemented an extension for VS Code, which is called Tools for Solidity. So if you just look at the VS Code marketplace, find this extension and hit install, it installs the extension, and on the background, it also installs Wake. So it's like one-click installation. And it's a front end for the framework. So what does it offer? Here you can see, for example, output of vulnerability detectors. And you see it in real time in your development environment, which means you don't have to run any tool over your code base. If you just like happen to have some kind of, reentrancy. So here you see like in real time that in this contract, there is a possible reentrancy. That's just the output of the Wake framework in your VS Code. And we also highlight, which means here you can see, again, possible reentrancy on this line. And one more cool feature, we also are able to calculate the test coverage. So basically, until your project is green like this, you don't have a written test, and you can see like visually which lines of code are covered by test and which are not. And if we compare again the extensions over the existing extensions, so our focus was to cover both the security aspect and the development aspect. So we believe like our extension, because it's the newest one, is the richest one in features. But of course there are the previous extensions that have much more users because they are longer on the space. But we, thanks to the Wake framework that's in the background, have kind of like advantage that we can also help with security. So these are the extensions, and if you would like to try Wake, you can do it right now. It's open source, it's free, and thank you. I think we still have time for some possible questions.